Okay, welcome back. This is the Virtual Residency Workshop 2021. It's Wednesday, June 9th, and it's the last session of the day. This is a set of lightning talks on research data management, and our moderator is Anita Schwartz from the University of Delaware. Anita, why don't you go ahead?
Great. Welcome everyone to the Research Data Management Lightning Talks and Panel. We really would like to have this to be an interactive discussion with all of you attending. Specifically, we all know that research data management has become an integral part of our jobs and our institutions or our organizations, and it continues to challenge us throughout the entire process, the life cycle of research projects. Today, what I'd like to do is introduce each of our panelists, and then they'll present a lightning talk to give their perspective on their roles and the challenges or use cases that they face, as well as any solutions or tools that they've implemented as a way to kind of drive this conversation. And I would appreciate if everyone would consider waiting until the end of the lightning talks. And while you're thinking of a question, I've posted in the chat a Google Doc that we have that we can share. If you think of a question, jot it down so that we can then address that to the panelists as we finish up each of their lightning talks. So I guess I wanted to just talk a little bit, introduce myself, and then I'll go ahead and introduce the next person. I'm from the University of Delaware, Anita Schwartz. I have over 30 years of experience supporting clients at UD. Prior to the formation of my current group, which is the Information Technology Central IT Research Cyber Infrastructure Group, I was part of research support in our IT client support and services group, providing general research computing support to our campus. 10 years ago, when UD designed and planned and implemented its first high performance computing community cluster, my job morphed into more of a research facilitator, which many of you have heard lots about that during this week. And mostly to help our clients understand and how to use our community cluster, which was myself including, by the way. My overall interest as of that experience is to really make HPC a transparent resource for the advances in research computing, including the necessary infrastructure needed to support all aspects of research projects, including research data management. So with that said, I'd like to go ahead and introduce the first panelist, Heather Amato from the University of California, Berkeley. Heather is a domain consultant for UC Berkeley Research IT, specializing in research data management and secure data research and compute. She provides support to researchers, especially those in public health. Heather is also a PhD candidate in environmental health sciences at UC Berkeley and an NIH Biomedical Big Data Fellow. With that said, Heather, take it away. You may share your slides and I'll stop sharing.
All right, thank you so much, Anita, for the introduction. Let's see if I can pull up my slides here. Okay, let's see if I can. I'm used to Google Slides, so trying to, okay.
Perfect.
Great, so let me just see if I can look at my notes here as well. If not, I'll just go ahead and get started.
If you don't have two screens, you won't be able to see your notes.
Yeah, I am unfortunately not at my normal office. So, okay, that's okay. I'll just go ahead and get started. Okay, well, thanks everyone for joining this late afternoon session, I guess, depending on where you are. I, again, I'm Heather Amato. I'm a domain consultant for UC Berkeley Research IT, and I'll talk a little bit about what that means and how research data management is and UC Berkeley Research IT is filling some important gaps that we've noticed in the research data world in the last couple of years. So first, just an overview of UC Berkeley's Research IT. We provide research data and computing technologies, consulting, and community for the UC Berkeley campus to advance research through IT innovation. And so we have a few different sort of like subsections within Research IT. Two major sections. We have our Berkeley Research Computing and Research Data Management. And so we have a number of domain consultants who sort of fall within a spectrum in terms of their expertise in both computing and data management. I'm somewhere in the middle here, like many of us. And we're domain consultants in that we have specialty areas or fields that we ourselves are in. So for example, my domain is public health as a public health researcher. So I think that's just important to highlight and is a really useful thing in terms of facilitating research, because as researchers ourselves in our different fields, we have a lot of great insights in terms of what researchers are looking for, what their specific needs are, what their data looks like, that sort of thing. And so in the last couple of years at Berkeley, we have picked up on a few really key needs across the campus in terms of research data. The first need being long-term data management, and the second being secure data management and computing. So in the past couple years, we have launched these two new services and platforms. So first we launched a RedCap trial instance, which involves a few smaller short-term projects and limited service capacity on our end. And the second service and tools that we've launched are the secure research data and compute platform. So this includes custom virtual machines, high performance computing cluster, and data storage. And so as a public health researcher, I'm coming into this with a sort of unique perspective as well. From my perspective, we see a lot of research that involves multi-year studies over several years, if not even perhaps a decade or more. We have a few really long-term multi-generational cohorts in the School of Public Health. And we also see a lot of highly sensitive data that needs to be secured, and both in terms of storage and computing, analyzing data, all of that. So we've built out platforms and service models for providing researchers with these resources in the last couple of years. And this work is still ongoing. We're still sort of in the early phases of these platforms. And so I just wanted to highlight a few of our key approaches in rolling these tools and services out, and in terms of identifying these needs in the first place. So I think the really unique thing about Berkeley Research IT is how we're able to conduct these really targeted outreach programs, because we have insiders like myself in the School of Public Health. A lot of times if we send out a blast email to the entire campus, everybody gets so many of those emails, we're not going to get as much of a response. But if faculty that I know personally and have worked with, if they see an email coming from me specifically or from one of my other colleagues in public health, they're much more likely to reach out and follow up on that. And so that's been really instrumental in terms of shaping our rollout plans and developing, and also targeting early users for testing these different platforms and helping us fine tune our service models as well. And another, I think, important aspect of our approach is that because we're really on top of tracking all of our consultations and everyone that we work with in terms of facilitating research data management, we were able to leverage this documented need for both RedCap and secure data management and request funding from main campus to support our service and resources. Another unique aspect, I think, that Berkeley and probably many other groups actually come with are that we have really strong partnerships and collaborations So with the launch of the REDCap trial instance, we partnered a lot with our sister school, the University of California, San Francisco. They have their own trial or their own REDCap instance. And so we learned a lot from them and worked with them to launch our own trial instance here at Berkeley. And then with the secure data management and computing side, we work a lot with the domain librarians and research data librarians, as well as the folks at the Lawrence Berkeley National Lab and HPC architects to build out those secure computing systems. We also provide really high touch consulting. I think that's another key aspect of our work and what makes us special at Berkeley. And it's been really, really useful in terms of rolling out these specific projects, because when especially you're in a pilot or trial program and rolling something out that's a little bit new and still needs a lot of tweaking, it's really important to have regular check-in meetings with your researchers and make sure that everything's moving forward, and we're tackling and documenting these any issues or nuanced things that might come up while we're rolling these things out. And that's really what helps us build great, accessible, thorough documentation that's really tailored to researchers and different groups. So I think that is about all I have. And yeah, I'll turn it back over to Anita, and I'm happy to answer questions later. Thanks so much.
Great, thank you, Heather. I'll just go through the list then. The next person that is on the list is Paige Morgan. Paige Morgan is from the University of Delaware. She's a digital publishing and copyright librarian, head of the Digital Scholarship and Publishing Services from the University of Delaware's Library, Museums, and Press. Paige has worked in the fields of digital scholarship and digital humanities as a researcher, instructor, data wrangler, and community curriculum builder for over 10 years at UD. She helps researchers and teams plan for publishing and disseminating research materials and data, as well as helping to answer questions about copyright and licensing. Take it away, Paige.
Thanks so much, Anita, and thanks to all of you for being here. Can you all see the slides that I've shared?
Can, but they're somehow
small.
miniaturized.
They're somehow miniaturized.
Try to reshare again.
Okay, let me stop the share and hang on one second. We're gonna put them over at present and
like they were like 1/8 of the size probably as normal.
Oh, that's bizarre. Okay, well, let me try one more thing that I hope will sort this out, and present and share. And how's that? Is that better?
Yep.
Yes. Okay. So thank you again. I will say that I call this talk, I have an alternate title for this talk, which is I wish I had a time machine, but I don't. So I will note that when I got started working with data on my very first data and computational analysis project, I was finishing my PhD, and I ended up pretty quickly with a spreadsheet that looked kind of like this one. It had over 100 columns, it had some color coding, and as I tried to build out my data set for my project, and as the parameters developed and changed, I found that trying to maintain it and build it took more and more time, and the data set, frankly, got more and more flawed, until I managed to get some time with someone with more experience with and managing data than I had. And he said, okay, first, if you have so many columns that you can't effectively manage your data set, that's a sign. And also, has anyone talked with you about data dictionaries? And as it turned out, no one had. This was back in 2008 or so, and a lot of the tools and techniques that we use for working with data, cleaning it, transforming it, analyzing it, weren't as widely used or taught as they are today, and people were doing the best they could. and finding their way to finish their research, get jobs, publish, and all of that. So today, I'm the person who's in a position to help people with unwieldy data sets that sometimes have been the product of years of intensive effort. I'm thinking of one particular data set that I helped someone with recently, which was over 12 years old. And it had been growing and was 30,000 lines, and was created at a time when there was not tons of support either. Happily, now that's changing, and I'm just one person on a larger team at UD that helps folks with research data management within the library, and that also works with other partners on campus, including Anita and the other folks in central IT, the folks who are supporting the high performance computing research cluster, and our research office. In the library, we get a range of questions, including the ones that I've listed on this slide. And the thing that I didn't realize before I got into this work is that I wasn't the only one who was muddling through and trying to figure out how to work with data without always knowing really the best practices to do it. Lots of researchers who I work with today began working with data 10, 20, 30 years ago when there wasn't widespread support for that work. And no one to tell them, you know, color coding your spreadsheet makes it easier for you to read, but it also makes it more complicated to use that data in various analytical tools or to build an interactive website on top of it. Researchers' focus is often on answering their research questions on a deadline or on getting the grant and finishing the grant and making things work despite time crunches, staff changes, and various other hurdles. In many ways, it's when they have really began to become successful or when they've reached the end of their career that they're starting to think about, well, wait, how do I make sure that this project lives on, that this data that I spent years with my lab working to create keeps on contributing to my research community, keeps on having an impact? How do I make it so that I'm not just putting my data out there into the giant black hole of the internet, but putting my data out there in a way that it gets used? What we're finding too in the library as we talk with researchers and ask questions is that for any given data set, it might look like it's all in the spreadsheet or TSV or R files. And spreadsheets we can preserve and save pretty easily, but in fact, I would estimate that only 75% of the data set is actually in the spreadsheet. The other 25%, it's really in the heads of the researcher or postdocs or lab assistants and grad students who actually are the ones working with the data regularly. So, and they are really deeply engaged with their projects, so deeply engaged that it's hard to step back and look at them from a distance. What we are really trying to do within the library, within our research data support group, is looking at projects and data from a distance and bearing in mind how folks have adapted, because of course we don't have a time machine, and thinking about what kind of documentation needs to be created. How do we take the expertise that is in the researchers' heads, the product of all their experience, and translate that into information that will help this research data get used or help it get found? Because just putting something on the internet doesn't guarantee anything. I think that institutions are working really hard to scale up their support for various sorts of data-focused and computational research, as well as research data management. But I think we're still seeing a lot of places where more support is needed. And one of the most powerful things we can do, the thing that's really closest to having not a time machine, but a good plan for the future, is really thinking about how we're training the grad students and future creators of research data, and working with departments and faculty and deans of colleges in order to advocate so that those future researchers get the support that they need. and training them and teaching them how to navigate these challenges is really one of the most exciting parts of the work that I and my team get to do. So I'll stop there. Thank you.
Great, thank you, Paige. I didn't get an opportunity because I think we were a little bit messed up on the sharing, but I did want to be able to at least keep putting the names up on the screen. And the slides are actually on the website as well. Under my name, at least the introductory slides. So I think Lynn is still having trouble connecting. So if it's okay with you, Vas, I'll go ahead and introduce you next.
Sure.
Great. Our next panelist is Vas. And if I say this incorrectly, please let me know. Vasiliadis.
Perfect.
Awesome. Who is also from the University of Chicago, representing the Globus team. Vas is a customer guy at Globus, a service for research data management developed and operated by the University of Chicago. Vas's goal is to make Globus sustainable so that every researcher in the world can use the amazing data management capabilities offered by the service. Vas is also a lecturer in the master's program in computer science at the university, where he teaches courses on on cloud computing and product management. With that, go ahead, Vas. I'll stop sharing.
Thank you. Thanks, Anita, and thanks everybody for the opportunity to chat with you. Let me get my slides up here. Let me know if you're seeing that okay.
Yes.
Okay, great. Sorry, I'm not, my monitors are playing up today. So yeah, as Anita said, I'm with the University of Chicago, but I'm kind of an odd duck. Not because my wife says so, but in this group, at least, I'm a little different in that I'm with a university, but I wear this hybrid hat where we have a service that we've built and operated for the last, it's almost 11 years now at the university, and something that's been around in various forms for over 25 years now, I believe. So, but I want to be careful to not sort of wear the hat of where I'm talking about the service and talk about more about what we've seen in achieving this mission, which is really to get these kinds of data management capabilities into the hands of everyone, not just sort of the privileged few that can make large investments in building cyber infrastructure for data management. So right now, or as of sort of a recent poll that we did, we have a lot of folks that use Globus in various forms. And again, this is not so much to talk about how great we're doing. It's more to talk about the fact that we've been working with a lot of research computing and data management teams, and we over the years we've seen things emerging, certain themes that emerge, and certain drivers of what of what's causing people to have to rethink or perhaps start thinking about more programmatically about how they handle data and how they make the lives of their investigators easier, because those folks are obviously focused on their research and really shouldn't be spending time dealing with all this ancillary data management IT stuff. So I'm going to talk about a couple of these things. So actually I've got three things. So thing one, which I call a clear and present danger, and this is not intended to imply that these wonderful institutions here represent a clear and present danger to us. Rather, the things that they provide, in particular the instruments that they operate on behalf of the broader research community in this case, or perhaps a campus like Purdue, are the things that are causing are making data management that much more critical and bringing it more to the forefront. So if you're familiar with cryo-electron microscopy or any of the advanced light sources out there, and certainly next-gen sequencing has been around for a long time now. So we have these literally thousands of instruments now all over the place that are generating, in some cases, tens of terabytes of data daily, and being able to sort of point and click and store and do things with your data is becoming really, really hard. So one of the questions that we see research computing teams grappling with is, how do we deal with these terabytes per day? In some cases, it's it's many hundreds of terabytes because they've got large facilities that are shared not just across campus but with other institutions, regionally, nationally. And dealing with the data doesn't just mean figuring out where to store it, which in itself can be a problem, but it's figuring out how most effectively to have it processed and shared across the various collaborators on a project, and making sure that all the various things, for instance, that Paige talked about, are maintained so that the data are useful to people. So that's the one thing. The next thing that we've seen, and I call this your USB drive is not fair. It's fair to use your USB drive just while you're working on things on your laptop or locally. But what I mean here by fair, and I'm sure many of you are familiar with this acronym, is having your data stored locally or in some unstructured manner or in a way that's not really accessible to others is really not the way to go nowadays. I think the notion of fairness, data fairness, I forget where it came from, but I first saw it in an NIH context a few years back. And I think since then it's been gaining traction as sort of a benchmark or a set of guidelines for dealing with data in quote unquote the right way. So making it findable, making sure that you've described your data so that people can find it and understand it, putting it somewhere where people can get to it, and structuring it in such a way that it's in standard formats and can be reused downstream and hopefully for many years to come. There are data sets that have been around, as we mentioned earlier, for many years. We just dealt with one from the Arecibo Observatory that failed a little while back, that has over 5 decades of observation data. So how do you make sure that irreplaceable body of data persists indefinitely? So one of the ways we're starting to see people do this is to put data portals or some type of interface in front of the data such that people can come along and search for data, find the things they need, giving them nice, easy ways to move that data to their own machine so they can look at it more closely, or they can move it to a campus HPC cluster or what have you. So, being able to do this in a sort of a modern way through web-based means, I think is becoming almost table stakes for anybody that's dealing with large data sets. And this is not just, I'm showing here a couple of examples from NCAR's Research Data Archive and the Materials Data Facility that's based here locally in the Chicago area. But this is becoming more of a need on even smaller projects with just a handful of investigators who want to put their data out there and really can't invest large amounts of money to build software. So there are we as Globus provide some of the tools to do that, but there's also increasingly groups that are collaborating to make this kind of capability much easier for people to deploy on their own. The next thing here is that your data don't belong to you. I apologize for the obscure reference. There's some of you may recognize that from games many decades ago. But the point I want to make here is that increasingly, you probably don't have control, or your researchers won't have full control over what they do with their data, in large part or in some part because they have to maintain compliance with certain things, or because of the nature of the data that they're working with, because it contains personally identifiable information, or it's somehow controlled unclassified, or what have you, potentially dealing with privacy requirements, which are a very important part everywhere, but particularly in Europe, which is one thing we're seeing. So being able to do things like, make the data available still, but provide granular control over who can see what, is kind of critical, because otherwise we put up these gates and people can't get to the data. So really the objective of the research computing teams in a lot of places are how do they reduce the friction that results from having to comply with all these things, such that researchers are not gated in doing their work. And so there's a number of mechanisms. We provide some things around search capabilities where you can control even who can see what in the search results, and also who can access data. So that's just, I picked on 3 things. We've seen lots and lots of other things, and I'd love to expand on them as we talk in the discussion, but that's, I'll leave it there for now and pass it back to Anita. Thank you.
Great, thank you, Vas. I understand that Lynn is connected via phone. Can you hear Lynn? Okay, can you actually unmute? Well, I guess I will go ahead and share my screen right now, and I'll go ahead and introduce our next panelist and see if we can get Lynn in towards the end.
Okay, so I think I unmuted.
Oh, good.
Finally.
Oh, excellent. Great, Lynn. I'm glad you could join us. If you could just hold on a second, will you be able to share slides?
No, I could not share at all with my with Zoom.
Okay, well, maybe I can share your slides maybe from the website then, and then maybe you can speak through them.
Yes, that would work, and you can. I'll tell you next when it's the next slide.
Perfect. That's great. Well, let me get through the official introduction of Lynn Pouchard from Brookhaven National Laboratory. Dr. Lynn Pouchard is a senior researcher who has led multiple interdisciplinary teams to create new approaches for data management, curation, and discovery for over 20 years. Her current research focuses on in workflows at scale, computational reproducibility, and enabling explainable and interpretable AI applied to domains of interest to the DOE, including extreme computing and scientific user facilities. She previously held research positions at Purdue University, Oak Ridge National Laboratory, and a joint appointment at the University of Tennessee, Knoxville. Please welcome Lynn Pouchard, and I'm going to go ahead and stop sharing and get your slides up. So give me 1 second. Wait, let me do this. Sorry, 1 second. I think I have to stop to go back again. Hold on. Where is it? There we go.
Thank you very much, Anita and Henry, for facilitating this meeting, and Anita, for your nice introduction. So I'm going to speak about the research data management challenges brought about by the ubiquitous use of artificial intelligence in science, both for researchers and also for the institutions. The next slide, please. So Anita, you should be on the slide that shows BNL capabilities. Is that correct?
Yes.
Okay, thank you. So Brookhaven National Lab is one of 17 DOE lab and one of the 5 DOE labs that are doing a general science program. We are located on the Long Island of New York, and we operate and support many data-rich facilities. In particular, we have the relativistic heavy ion collider, which was the first collider ever built, and the second one is the one built that you all know at CERN. We have the National Synchrotron Light Source 2, which is a newer energy producing light source. What else? We have a lot of other facilities like the Center for Functional Nanomaterial, accelerated test facilities. We're also working with the Atmospheric Radiation Measurement Program, which is an environmental science at for DOE. So BNL has the largest scientific archive in the US, and among one of the top 5 in the world. The others are the ECMWF, the weather forecasting system of the European Union, CERN, and NOAA. So for the 2019 data, we have 150 petabyte archive to date, with 690 petabytes analyzed in FY12, and 110 petabytes of data transfer per year. So we're a very active archive. And we're also building a quantum chromodynamics facility and a cryo-EM facility. So please come and work with us if there are candidates out there. Please look us up, and if you're interested in jobs. And I apologize for the shameless plug-in. So I would like to talk about the challenges that research data management brings about in the use of AI for science. And first, by looking at what it takes to build an AI application in science. And the first thing and the most important thing is the collaboration, the interdisciplinary collaborations that need to be, and that's the next slide. Sorry, I forgot to say that.
I already put it up. So this
What?
is what does it, I put the slide up. What does it take to build an AI application for science?
Yes, that's correct. Thank you.
Mm-hmm.
So the interdisciplinary collaborations that are needed are people, researchers and scientists from different backgrounds and having different goals and purposes, in particular computational scientists, experimentalists, and data scientists. And for building an AI application for science, first we need to identify emerging phenomena, which often occur in high velocity and possibly streaming data. Determine what is of interest and impact, generate candidate explanations. There's also an important aspect of AI, which is human-computer collaboration to jointly adjust the data collection, reasoning, and insights. In science, a lot of the models that are being used come with a lot of uncertainty, and often and we've done some experiments related to that. In the AI literature, the best algorithms, the one that has the best performance accuracy, are the one reported, and yet these are not the most robust ones. And that has a lot of implications for research data management, because how do we make sure that these the best algorithms for not only the best results, but also the most reproducible results for scientific experiments are the ones that are being reported. Then the human in the loop also evaluates the impact of the possible decisions. And these decisions need to be documented, which is where provenance, explainability, reproducibility is involved, and where research data management plays a key role. Next slide, please.
Done.
Artificial intelligence introduces new challenges to curation and research data management. In particular, FAIR is designed for data, but not data and software. So there are new criteria and research objects that needs to be traced, such as training sets, models, hyperparameters, calibration. The size of the training sets and their availability are challenges for reproducing the results, which is one of the key tenets of the scientific method. Often the results, at least in the papers that are produced, only show perhaps the model. So you have the structure of the model, and if you're lucky, you're going to have some of the original data for the used as input. But the training sets are not available, and the size of these training sets is obviously a challenge. There's also a lack of precision and accuracy in the metadata for the input data, and that can compromise the quality for artificial intelligence models. So data sets with incomplete results should not be used. Data sets with incorrect records introduce errors. And there is also a lack of adequate data sets in some disciplines, despite the abundance. For instance, in material science, the studies that have shown that there's not enough diversity of data sets in large databases. So you have large databases that are very well documented and that are provided to the scientists to use, but they only contain a very specific type of data, and that is not sufficient sometimes for coming up with robust artificial intelligence results. There's also not enough diversity of some data sets, and the databases that have enough of breadth usually do not have enough data for training those models. Next slide, please.
Go ahead.
So some of the additional challenges include what do we store? What do we annotate? And these are challenges for the researcher. They have to decide what are the things that they need to make available, because AI is a black box. Then other challenges are how do we annotate decision points that are made by the black box model. So some some of the examples are the documentation, the metadata, the provenance. So what do you document? So some researchers recommend you document the method, you document the data, you document the experiments, which variables affect the reproducibility and replicability. On the right-hand side, you have a diagram of an input script for a machine learning model that we attempted to reproduce. So that in this particular case, that was a material science experiment. It was the same researcher who was reproducing his own machine learning experiment with the same data, same researcher, same experiment, and we could still see a great variety of results. There was variety in the machine learning platforms that were being used. So sometimes TensorFlow and PyTorch for it was a multi-layer perceptron did not always reproduce the results. sometimes different versions of the same platform do not reproduce the results. So there is a variability there. And this is like an open secret in the artificial intelligence community, that because they use these platforms so continuously, when something changes, let's say there's a new release of TensorFlow or PyTorch, sometimes with the new platform, the results do not necessarily reproduce, and sometimes it does, sometimes it doesn't. So in our case, it did, but the researcher said, well, it's only because we were lucky. In this particular case, the underlying machine learning platform had not changed enough so that our results would be the same. And this is available in this is like one of my publications. I can send the details if somebody's interested. There's also the availability of the compute environments for machine learning. There are specialized architectures that affect the results, and they're also increasingly high performance computing and AI are linked for science, because there's such a demand for compute cycles, notably what is provided by GPUs, and that the high performance computing architectures that do have these GPUs are being used for machine learning. So how does this, what are the implications for reproducing your results, and therefore for research data management? And finally, with the use of surrogate models, to what extent do they provide some measure of reproducibility? And some of the main conferences in high performance computing, like SC20, the supercomputing has had a reproducibility initiative since 2017. There's also an artificial intelligence conference is having also expecting the people who submit papers to have a whole checklist and fill that out. And this is part of the submission and part of the evaluation. So there are efforts, but these are efforts on the part of the researchers and the scientists and the conferences. But there are also challenges for the institutions that are going to have to host this data. Next slide, please.
Go ahead.
And this is my last slide. There's so what I gave you on the right hand side was r3data.org, which is a repository of data repositories, and you can search for machine learning, artificial intelligence in this registry, and you have at least 5 or 6 different repositories. Among those, I selected OpenML and DL Hub. Also, maybe Vas can talk about that a little bit more. It's also at the University of Chicago. In this artificial intelligence ecosystem, we have the archival space, the working space, and the scratch space, and the data that we need to preserve in order to be able to reproduce these experiments is what is in the working space. So where will the AI provenance go? Is it going to go in specialized repositories? Is it going to go in publishers' repositories or institutional repositories? And this is the question, obviously, for the future and for the debate. Thank you very much. This is.
Thank you, Lynn. Well, last but not least, I'd like to introduce our last panelist, which is Scott Yokel from the University of Harvard. He is the Director of Research Computing. Scott joined Harvard in February 2015 to lead HPC group supporting science and engineering. And in 2017, he transitioned to the University Research Computing Office, 2, University Research Computing Officer. In addition, he is actively involved in Campus Champions, leading Region 7, and CARC, co-leading RCD Professionalization Working Group. Having been on both sides of HPC as a researcher and administrator, he values the importance of providing efficient and streamlined computing and data resources that expedite the process of scientific breakthroughs. His research domain expertise is in computational chemistry with an overlap of material science and mechanical engineering. So I'd like to welcome Scott as our last panelist, lightning talk.
So much. Share. All right, everybody can see that?
Yeah.
Trying to get rid of all the extra zoom on top of my slides. So today it's me instead of Mercedes. Mercedes Crosses is our University Research Data Management Officer. We'll talk a little bit about the types of things that we're doing at Harvard and try to move towards creating the data commons, MVP, to address a number of the things that like Vas talked about as far as the movement of data and things like that. Also things that Lynn talked about, that data and software both need to go together to create something like a CI/CD platform. Other things that were touched on in the libraries, like access to data, sharing of data, various different repositories, and try to connect those things together. So one of the biggest challenges, like since I've been to Harvard, I feel like I've been exposed to data in a whole new way because the growth of data is so pronounced. I feel like every 3 years we have about a 10x increase in data. And it just becomes really unwieldy at certain levels. When you get to certain capacities, it's hard for people to move data. So I generally say, like, when you have more than a terabyte a day, you can't move that over a 1 gig network, no matter how tuned it is and how good your applications are. Once you start having to go to a 10 gig network to move data, if you're trying to do something like 10 terabytes a day, which we have a multi-headed scanning electron microscopy that has 61 scanning electron microscopy pictures at once, like, it becomes unwieldy at that point. You can't use normal ways that which you used things before. So luckily things like Globus have been helpful in coordinating movement of data, but still you have to be really organized with it. And where that's hard is that, so if you look at one of these, there's been a few different studies across how are we doing with research data services. And one of the things that you'll see is that there are places where we do this in libraries and IT. Those are the main providers, and it's mostly consulting and training, right? There is a little bit of back-end, there's a little bit of front-end development, but there's not a lot, right? That's not where we spend the majority of our time. And then there is a significant amount of this kind of data management support, but it happens outside of library and IT, and it happens in kind of domain-specific spaces. So statistics is like a place where you see a lot of that. Maybe we're going to call it, in data science space as well now, or informatics or other geospatial types of things. So that's where you see a lot of those kinds of research data services. And because they're distributed across a large comprehensive university, it makes it really challenging. You have lots of silos of the ways in which you're doing this. And that's where at an institutional level becomes really kind of unwieldy. And just to kind of bring you up to speed on how much data am I talking about? So in Harvard, we kind of have 4 research computing groups. We have the Faculty of Arts and Sciences, which I manage, the Medical School Research Computing Institute of Quantitative Social Science, which is kind of a multidisciplinary space, and then the Business School. And across that, we're talking about close to 200 petabytes of data that's out there in the research space. That's really unwieldy at this point. So at Harvard, we just recently put in a kind of small internal proposal to kind of make a headway at creating what we're calling the Harvard Data Commons. We really want to improve the researcher experience, right? The researcher experience right now is mostly very ad hoc. It's very command line driven. It's not the way in which any of the normal cloud tools operate, right? And so we internally say more pointy clicky. That's what they need. That's the interface that they want to be at, and they need on the backside of that to have robust things happen. And they need to have this happen not at the beginning or the end of the life cycle of their data, but all throughout, right? So manage the environment from research computing, make publication, make preservation, make that all as a part of a package or what we call a platform, of things that can interact. And there are different parts of Harvard that are doing that. And so that means that in the research computing space, in the data management space, and the libraries, we're all trying to now work together on a common goal here. And in doing that, if we provide them with better tooling, hopefully we will bring up the level of data integrity, provenance, reproducibility that are all really important that we've heard about already today. So this is a lot of words because this is like straight up a slide deck that is like the one slide that we pitched internally to get some funding to do this. So this is the style of like enterprise IT style. So our objectives are kind of threefold, and then we'll be doing this throughout the year, is to take a repository-like Dataverse, which normally is used at the end and during the publication of a data set. So it's a great for mentioning in DOI, for sharing, for that type of thing. But what we haven't done is introduce that concept earlier in the research process. So we want to integrate Dataverse, which is like the destination, earlier in the process. So people can publish metadata early before the data set is actually available to the public. So they can keep track of the metadata, they can register the data sets as it's still sitting on the research computing storage space. We also want to make it easier for them to move large amounts of data. So instead of using the interface that is largely like Java and HTTP driven behind the scenes, we want to use things like Globus, right? So we have another institution in Canada that's already done that. So we want to incorporate that so we can move data quickly in large amounts of data. And we want to support much larger data sets than was originally thought for it. And then we also want to advance support not just the data, but putting the workflows. So we want to be able to register like digital object or research objects of like the computational notebook, of something like an electronic lab notebook. We want to integrate those things as part of the package of registering your data set, right? And describing those types of things. And then the other thing is that there's a rich, the Harvard library system in itself is a huge set of different repositories, from geospatial to poetry to all sorts of different imagery and stuff like that. And so at this point, we want to take two of them, which is the digital repository service. So it's like long-term preservation, keeping copies in 4 different locations on disk and tape and stuff like that, as well as the Dash, which is where if you want to publish your publication or your like thesis and dissertation in an open access way, they all go into this repository called Dash at Harvard. So that way we can connect the data set to the actual publication, and you can see all of it in one collection. And then the metadata for all of those other things is part of the Dataverse metadata. So things that we're interested in is creating technology that follows best practices. So instead of just giving and pushing out from kind of more a data management policy space, let's actually create those tooling and then help contribute to their best practices in that manner. Where we can, we're going to use open source, build upon standards for communication between different platforms, having some common APIs. And so the thing that we're building is kind of the glue code between some of these different technologies. And we need to make sure we engage researchers. Like us as technologists, we think it's kind of fun to build these tools and stuff, but if we don't engage with the researchers, we won't understand what their thoughts are on the workflow and how they imagined it. So we have a set of researchers we work with. We definitely can't do all this by ourselves. This is just an MVP for a year. We had a workshop in the late fall of last year where we engaged with 30 institutions, and we're trying to come about with a couple of other little projects and things that we will do along the way. And then what would success look like? Well, one thing is the connector tools that we build will be well-documented code that we can share with everybody, that we are creating some standards for how we use different common workflow artifacts and use that in how we describe that metadata. We can do large data sets, like I said before, and then integrate multiple other things. So that's a lot of text, a lot of talking. This is an image that I actually showed last year. And so the concept hasn't changed much. Our funding that we tried for last year actually didn't exist, so we didn't really get anywhere last year. But this is kind of the concept diagram. So Dataverse as itself, like the Harvard Dataverse, is a rich 30,000 data set. It's probably larger than that. That's the data from last year. Huge amount of files deposited, but that does not include any type of sensitive data, and it should in the future. It doesn't include large, massive types of data where you have like terabytes upon terabytes of data sets, right? These are much smaller. So as we support larger things, we need to think about how do we move data and describe data, and like I said before. And so the concept in the middle is that upon data acquisition, whether it's from an instrument or you're getting this data from, externally, or survey data, we want to be able to store that in a place that is next to the computing or the data analysis space, right? That's typically what we do. We want to make sure that we have, that kind of thing backed up. And then what we can also do at that same time, as a part of, say, backing it up, it would be to organize our data in a way that we register it with the data commons, and then we can publish that data. And then when you get to the point where you need to you would publish it to the data repository, but you wouldn't create a DOI until you were ready to share it, right? So it kind of adds, some extra space there. And the types of tools that we're talking about are electronic notebooks, right? Something like RSpace. Computational notebooks would be like R and Jupyter and other various things, MATLAB, or maybe it's just straight up Git code. And then we need to move the data. Like I said, Globus is providing us that. And then we need to have some kind of way to have policy-based movement of data, or policy-based decisions about data, which is the place that we need to get users away from having to touch files on the command line when they want to do things. And so something like Starfish, we're looking at things like that allow us to do and describe data, and us on the administrative side then can create actions based upon different tagging and policy. And that helps automate a lot of this workflow for the end user. So that's kind of my summary of where we're headed. And I think that's the end of our lightning stuff. So I'll stop sharing.
Great, thank you, Scott. Before I start asking any other questions to the panelists, at this point, does anybody have a burning question after listening to all of the panelists that they would be interested in asking? I didn't see any questions in the document, in the shared document. So I'm kind of opening it up to the people that are still on the call that would like to ask any questions. Not a burning question? Not one, huh? Okay, well then we're prepared at this point. And so I'm trying to decide, at least for the panelists, it seems like there was a lot of different cross discussions about the techniques that people are using. And so I would like to just ask if any one of the panelists that brought up different aspects of the research data management and their perspective, if they have a use case or something that they would like to expand upon from their original lightning talk. For example, Vas, did you want to give any specific use cases about Globus? Or I think Heather mentioned that, and Scott also mentioned that, and Lynn also mentioned that as well with respect to the transferring or moving of data.
Yeah, I can talk briefly to that. We have tons of examples of where data movement is a problem, but as Scott said, it's rapidly becoming not the key issue, because sometimes it's not about moving the data. It's more about finding the data and then getting little bits of it and doing other things to it and making those bits available to people. So we're what we're seeing more and more of is, I mean, Harvard's ambitious has a much more ambitious thing with this data commons, but we're starting to see a lot of people looking at slightly narrower scoped data portals, data commons, science gateways. People have different terminology for the same sort of thing, and unfortunately, it does require bringing together a lot of moving parts. So there's diverse skill sets that are required, and it's also hard to translate the requirements of the researchers in a general way such that you can build something that's useful to everyone. So a lot of times people are building these point solutions. So like what Harvard's trying to do is build something that's much more generally applicable. That's a much harder problem. I'm looking forward to working on more of those. I think this is going to be a lot of work over many years to get to points where people can just plug and play and voila, I have all my data in a nice browser and all that's ready.
Exactly. I think a number of people have mentioned in the past that it's very difficult to meet all the different needs of what people are trying to do. And so I think that is, amazing that, Harvard's able to look at that. And I was just wondering, Lynn or Scott or anybody else want to comment on that? Or Heather, I think you mentioned something about that as well. And you're working with secure data, which is a whole nother level of complexity as well.
Yeah, I can just briefly speak about the secure data issue, especially with data transfer. So for example, I work, I'm helping with consulting on building out these custom secure virtual machines. And it is really hard to come up with a model that is broadly applicable for researchers across different domains across campus. But we have some, while we were in the sort of testing phase, and we were working really closely with research groups that we're really familiar with, and they're, we worked with them on a number of different projects, but beyond the secure data stuff. And I think, yeah, just learning from the researchers and building out from there, and making sure that, as I think Scott mentioned, just we're really engaging with the researchers early on, and understanding, yeah, what their specific needs are. So I think, and in terms of, with data transfer, I was just on a call earlier today with a researcher who was trying to bring data out of the secure environment, and, was hitting roadblocks there. And so I just wanted to echo that it's really tough to build like a catch-all solution. But one thing that we were doing that I think is really helpful, or hopefully will be really helpful with the researchers, is we're building out these test virtual machines that are sort of your standard machine that has like, the bare minimum programs and software tools, that sort of thing. And so researchers, while they're waiting to access their data, or while they're waiting to get all the IRB stuff in place or whatever, they can log in and get access to a virtual machine that will look a lot like the one that will spin up for them, that is custom for their needs. And so those test environments, they'll have like sample data sets and some sample code that they can test and run the performance of the machine. So those types of solutions, it's a little bit easier to make something, make up a test environment that's applicable to a variety of researchers, and then we can fine tune things for them after they've done some testing on the environments. But yeah, it's really hard to build out these catch-all systems. Yeah.
One of the challenges in engaging with researchers is sometimes it's really hard to get them out of their like here and now today problem and to get them to think at a higher level of like, can we solve this problem for like your whole domain, instead of just you as an individual researcher, individual research group. And I think that's like, we're trying to push to do some of that in the data commons. Like, what are the common themes? Some of the places it's been more apparent is like when you, like at Harvard, we started a few years ago, a research computing and data council, where like everybody who's engaged across all of the campus and all sorts of different pockets of campus. So like Kennedy School, Design School, right? Graduate School of Design has research computing, right? Needs and stuff. So like when you start to engage in places outside of the typical science and life sciences, health sciences and stuff, then you start to see there's some commonality of real friction issues that are around some really similar points. They all come to them in a different way, but I think that's when you can start to think about generalizing them. And I don't think they would know that. It's only us that talk to all of them. They don't talk to each other across those different domains like we do. So we're in a new space to do that, but it is challenging.
Yes, exactly. And I know that we're running up to the time already. Unfortunately, we started late, and I don't think we should try to keep everybody too late unless somebody has some last burning question. I know that there was a couple comments. I'm trying to put them all in the document that we had regarding the actual panel. So without further ado, if there's any other last comments from the group, I know Paige talked a lot about training and documentation and awareness, and that is so important at all of these levels, and getting everybody together on the same page, especially when we're talking about domains and researchers having different conceptions. So I just want to thank all the panelists. All the slides are up there as well. Please don't hesitate to reach out, at least to me, if you have any questions beyond this or you need any help. And thank you so much to Henry for coordinating all of this. It's takes a whole village to get us all together to bring together this type of information that's so valuable to our entire community. So thank you.
Thank you all for a terrific panel. I really appreciate y'all working on this together. I'm going to shut off the recording for just a moment.